Okay, so this lesson is for Mrs. Cucci's College Now Precalculus class. We are on file 4.3, Logarithmic Functions and Graphs. We are on page 2.1, so go ahead and open that up. Okay, so what we're going to be talking about today is converting between exponential equations and logarithmic equations. So going back and forth from log base b of x equals y and changing that over to x equals b to the y. Okay, the log is an exponent. Okay. So if you remember correctly from last year, we said blood alcohol content logs break children's arms was like our key phrase, how we remember how to go back and forth. So what we're going to do is we're going to take 16 equals 2 to the x and we're going to put that into log form. So again, if it helps you to write it down, feel free to write it down. Okay, so how we go back and forth. So just keep track of where those variables are. Your base for this is going to be 2. That's what the exponent sits on. That's our base. So our base becomes b for our log, our base. So log base 2 of c, which is what it's equal to, 16. And that equals, in our case, x. Okay, so we're just converting it to a log equation. We don't need to solve it. I just want you to make sure that you guys can go back and forth between the two. All right, so let's try another one. So 10 to the negative 3 equals 0.001. So again, it's going to be log base 10. So this is a common log. We don't have to write the 10. It's kind of known, but if you'd like to put it in, that's fine. Of 0.001, and that equals negative 3. Okay. God bless me. Okay. So this last one, log base e of 70 equals t. And if you remember correctly, log base e is our natural logarithm. So we don't write log base e. What we write is ln of 70 equals t. Okay? All right, so we're going to convert this to exponential, so now we're going in the opposite direction. The base to our exponential is what our logarithm is sitting on here, and that's our 2. So this becomes 2 raised to the 5th power equals 32. Okay, and you could always check this. My mistake, I've got that written in there kind of funny. Raised to the 5th power equals 32. So you can always check this to make sure that it's correct, just by throwing it in the calculator and saying, all right, is 2 to the 5th 32? Good, it checks. Okay, and it should check for you. Okay, so again, base here is a. Raised to the 8th power, exponent is what it's equal to, equals q. Okay. Convert to exponential again. So again, our base is t. our exponent will be x, and it will equal m. What am I doing? Oh. And there it is. All right, so now let's talk about natural logs. Again, natural logs have a base of e. So ln of x just means log base e of x. Same thing, it's just different notation. All right, so ln of 1 is always equal to 0, and ln of e is always equal to 1. These are ones that you should just kind of know as we go through these. All right, so let's talk about change of base formula. For any log bases a and b and any positive number m, we have this formula that allows us to change the base of a logarithm so that they have the same base so we can work with them. Okay, so if I have log base a of m, if I have log base b of m, what I can do is I can take log base a of m and divide it by log base a of b. And we'll see what this looks like in just a minute. So just keep in mind this formula here. Okay. All right, so find log base 5 of 8 using common logarithms. Okay, because this wants us to find log base 5 of 8 using common logs. Remember, a common log is a logarithm with a base of 10. So what we're going to do is we're first going to let a equal 10. We're going to let b equal 5, our original base, and m equal 8. Okay, then we're going to substitute it into our change of base formula. So we have log base 5 of 8, which is our original, equals log base 10, our new base, of 8 divided by log base 10 of 5. Okay, and all we're going to do is we're going to plug that right into our calculator, this piece here, and it's going to give us a value of approximately 1.2920. Okay, so since log base 5 of 8 is the power to which we raise 5 to get 8, we could expect that the power would be greater than 1 and less than 2. So that just gives you an idea of what would be reasonable. Okay. So now we're going to try it using natural logarithms. And again, natural logarithm has a base of e. So we're going to substitute e in for a instead of 10. Okay, so we're going to use e here. And we're going to set this up again, but this time using the base of e. So remember, log base e is the same thing as ln. So you're going to have ln of 8 divided by ln of 5. Put that right into our calculator, and we get the same approximation, which we should. Okay, so either way, using a common log or a natural log, we're going to get the same approximation. Okay, so the next thing we're going to do is we're going to start to graph log functions. Okay, so the first one we're going to graph is f of x equals log base 5 of x. And what we're going to do is we're going to start by creating a table. Okay. Now keep in mind that f of x is the same thing as y. So if it's easier for you to see it like that, you can rewrite it. Also, this is equivalent to x equals 5y. Okay, 5 to the y. All I did was I took that and I put it into exponential form. So this may help when we want to try and find values to graph. Okay. So we've got our x and our y. And let's start with the value of 0. So again, we're going to start plugging in for y first, because plugging in for 0 for x is going to be more difficult for us to solve. So if y is 0, 5 to the 0 power is 1. Now let's check 1. 5 to the first power is 5. Okay, 2. 5 squared is 25. That's it.
Thank you.
3, you're welcome, is 125. Now let's get some negative values as well. Negative 1, 5 to the negative 1 is 1/5. Negative 2 would be 1 over 25. All right, so that gives us some values that we can graph. Okay. So I'm just going to create my graph. Well, now we're going to plot. So we got 1, 0, 5, 1, and then 25, 2 is going to be way out here somewhere. Okay, so let's go back the other way. 3, 125, 3 is going to be way out here. 1/5, negative 1, so really close here. 1/25, negative 2 is going to be really close. So what we wind up getting is something that looks like this, and it's going to jut out like this. So again, notice it gets arbitrarily close to that y-axis, which is telling us that we have a vertical asymptote at x equals 0. Okay. All right. Now we could also very easily graph this in our graphing calculator. Log base 5 of x. So Control I, add graphs. Log base 5 of x. And we're going to get the same general picture. Now it looks like this ends, but it doesn't. It continues to go down and get arbitrarily close to that axis. Calculator doesn't do a great job of showing that. Okay. So the next one we're going to look at is the natural log of x. Remember, that gives us a base of e. Now for the sake of time, we're just going to take a look at what that looks like in our calculator. ln of x. And here's our function. Okay. Notice all log functions generally have the same shape. They don't differ a whole lot other than how quickly they increase. Okay. Okay, so we're going to graph each of the following. And before we do so, we're going to describe how each graph can be obtained from the graph ln of x. Give the domain and the vertical asymptote of each function. Then check your graph with a graphing calculator. All right, so we have spent a lot of time talking about how these functions get transformed. Okay, adding or subtracting directly to the x gives us horizontal translations. Adding and subtracting to the entire functions give us vertical. Okay, so we've really talked about this stuff in length. What I'm going to have you guys do is I want you to do these out on graph paper. And on each graph, I want you to give me a description of how it has changed from its parent function. Okay, you're going to be turning these into me. So again, you're graphing these three on graph paper, and you're describing the translation from the parent function. Okay, so we're going to stop here, and I'm going to make sure that you turn those in next class to make sure that they get done, and come prepared with any questions. All right, guys, thanks.